Hi students, in this video we are going to start the new chapter, that is logarithms. Before we get into logarithm concept, we must know why we study this concept. You just look at this, we know that 2 cube is equal to 8 and 2 power 5 is equal to 32. But if we are asked to calculate 2 power 5.732, I know that it will be difficult for us to solve to get the answer. Now you look at the next question, that is cube root of 27 is, we know that the answer is 3. Similarly, cube root of 64 is 4. And if the question is 7.123 root of 64 is what? We know that it will be difficult to solve this. In order to solve this kind of difficult problem, mathematicians introduced a new concept. That concept is called as logarithms. In this chapter, we are going to learn about some basic introduction of logarithms. You just look at this, consider this 2 power 3 is 8. This is in the exponent form because one number is raised to another number. This is called as exponential. So exponential concept. So it is exponent form. Now we are going to convert these numbers from exponent form to logarithmic form. Just we are changing the form of this number, but we are not changing the values. It is being converted into some other form. For example, 5 into 2 can be written as 10. The same 10, 5 into 2 is equal to 10. It is in the multiplication form. We can convert this 10 as 20 divided by 2, which is also equal to 10. We have written the same value of 10 in division form, that is 20 by 2. Similarly, here 2 cube is equal to 8 is in the exponent form. We are going to convert this exponent form into logarithmic form. So we have to follow certain rules. We cannot question why it comes, how it comes. Just we need to follow the technique to convert this exponent into logarithmic form. They say that base must be same. Here base is 2. Here also logarithmic base is 2. But this 8 comes here. The power 3 goes to opposite side. This has to be read like log 8 to the base 2 is equal to 3. I am repeating the sentence once again. Log 8 to the base 2 is equal to 3. So we know now learned how to convert exponent form into logarithmic form. The base must be same. The right hand side value should come to the left hand side and the power in the left hand side should go to the right hand side of the equation. This is how we will convert exponent form into logarithmic form. Now we have taken the example by which I explained you how to convert exponent form into logarithmic form. Now based on the knowledge we gained here, we will generalize the concept. You just look at this. If a power x is equal to n, we know that it is in the exponent form. In order to convert this into logarithmic form, we have to write this as log n to the base a is equal to x. I hope now you are very clear how to convert exponent form into logarithmic form. Sometimes the question will be asked that logarithmic form will be given, we will be asked to find out exponential form. So log n to the base a is equal to x means it's exponential form. The base will be same a, but this x go to the power and n go to the right hand side of the equation. I hope you understand this. Now we will get into definition of logarithmic form. The definition of logarithmic form is if a power x is equal to n. Here base value, that is the base a, should be greater than 0 and a should not be equal to 1. This condition must be satisfied. Otherwise logarithmic concept cannot be applied. I will explain you later in this video why it has to be the base value should be greater than 0 and base value should not be equal to 1. I will explain it later. Now I will read out the definition. If a power x is equal to n, given that a is greater than 0 and a is not equal to 1, then the index x is called the logarithms of the number n. The x is called, the index x is called the logarithms of the number n with respect to the base a. You just look at this. I am converting now. A power x is equal to n, where x belongs to real number and a should be greater than 0 and a should not be equal to 1. These conditions are very important, and then we are converting it into logarithmic form. So log n to the base a is equal to x. Now you just again go back to this definition and read, if a power x is equal to n, where a is greater than 0 and a is not equal to 1 and x belongs to real number, means the index x is means this equal to sign is called logarithm of n, logarithm of the number n with respect to base a. I hope you understand this. Now I will tell you why base value should be greater than 0 and why base value should not be equal to 1. Now you just come to this. First I explain why a value should not be 1. What happens if a value is equal to 1? If a value, that is base value, is equal to 1 means the exponential form appears like this. 1 power x is equal to 1. Now you know that whatever might be the power, if the base is 1 means answer is 1. 1 power 1 is 1, 1 power 2 is 1, 1 power 3 is 1. Actually the aim of logarithmic function is to convert the tough problem into somewhat easy problem. Here we need not apply logarithm. As soon as you look at the question 1 power anything is 1, we can say it. We need not use logarithm. That's why they say that base value should not be equal to 1, because a value is equal to 1 means definitely answer will be 1 only. I hope you understand this. Now we will come to see what happens if a is less than 0. Actually they say that a must be positive number. We are taking an example in which a value is negative, that is a is less than 0. I am taking an example. A base value is minus 2, which is negative number. I am raising to the power half because x belongs to, you just look at this, power x belongs to real number. I am raising that to power half, so it can be written as square root of minus 2. We know that we cannot calculate square root for a negative number. Actually square root of minus 2 is equal to I root 2. I is an imaginary number. This does not come under real number, but here we should get real number as an answer, but here it is an imaginary number. So when we use base value as negative numbers, it goes to imaginary numbers. You will learn about imaginary numbers in the mid of 11th standard. Right now just know that it is a imaginary number. That's why the condition says that a value must be, that is base value must be positive number, that is greater than 0, but a value should not be equal to 1. I hope you understand this concept. X value belongs to real number because our aim is to calculate the tough problem into easy problem. You just look at this example here. X value, the power value is 5.732. It is a real number. Only when we have real number here like this, decimal numbers are like this, the difficulty arises. That's why they say that x, the power x, can be real number. I hope you understand this concept. Due to the time limit, I am completing the video now. In the next video, we will continue our discussion. Thank you students. Thanks for your cooperation.